Okay, the last two slides have to do with crashing. And again, as you recall, crashing is shortening the overall length of the project by adding resources. So what we need to do to shorten the overall length of a project is we need to shorten critical path activities. If we shorten a non-critical path activity, it's not going to shorten the overall project. It's just going to shorten that path. So the first thing to remember is we're only going to focus on critical path activities. Those are the ones we're going to focus on. And then the second thing to remember is if you have a choice between shortening various critical path activities, you're going to pick the cheapest one. All right, because if you can shave a week off for $500 or shave a week off for $200, why would you spend the $500? You'd want to spend as little as possible, as long as you could shorten the project by a week. Okay, so this is example 18 from the end of the chapter, and it gives you the original times, how much you can crash to. So the crash time available, this is equal to the time minus the crash to. So the 6 minus the 5 is the 1. Okay, the 8 minus the 6 is the 2. So instead of just telling you how much you could crash it, it just gives you total time minus how much you could crash it to. So you have to calculate the crash amount available. So for activity A, you can take 1 week off of it. All right, that's basically what crash available means. You can only crash it for 1 week. And then in terms of the costs, you have to calculate those. Crash per day is just going to be the crash cost minus the normal cost divided by how much crash is available. All right, so I have the formula over here, but this is the second to the last column that's how much it costs per day to crash each of these activities. Okay, so you have to do a little bit of work to translate some of these data into something meaningful that you can use. So any questions on where I got crash available and how much it costs per day to crash? Okay, so the next thing you have to do is you have to identify the paths. So you can see that this network, there are 3 paths. There's AD, there's B, and there's CE. If you look at these 3 paths, you can see that path CE is the critical path. All right, so if you're going to shorten this path from 12 to 11, you have to shorten either C or E. All right, so what I have here, so if you don't crash anything, 0-day crashed. C, you have CE is 12, that's your longest path. So that's where you want to focus, crashing your activities. So if I want to go from 12 to 11, and if I want to crash 1 day off, I'm going to look, then I come up here and I look at, I can take a day off of C, and I can take a day off of, or I can take up to 3 days off of E. But C is the cheapest one. C is only $100 per day. E is $200 per day. So I'm going to pick C. I'm going to crash C once to go from 12 to 11, and it's going to cost me $100. Okay, so that's what I did, is I focused on my critical path, and I focused on the cheapest activity in my critical path to crash. So by crashing, or for spending $100, I have shortened activity C from 4 days to 3 days. All right, so any questions on how I went from 12 to 11? Okay, so notice after I did the first week, now I have 2 critical paths. I have path CE is 11, and I have path AD is at 11. So to shorten this down to 10, I have to take, crash one activity from each path. C is no longer available. It was only available to crash once, and I already crashed it. So that one's gone. So to go from 11 to 10 on CE, I'm going to have to go with E. I can use E 3 times. It's going to cost me $200 each time. So to crash CE from 11 to 10 days, I have to spend the $200. I also have to go on AD because that one is at 11 days also. So if I look at A and D, A is $100, D is $150. So I'm going to crash A. It's the cheapest one. And so again, to go from 11 to 10, I'm going to spend an additional $300 and, crash activity A and E. Okay, so everybody okay with moving down now to 10 days? Any questions? Okay, so this particular example wanted us to crash 4 days. So now you look, after we crashed down to 10, we still have 2 critical paths. So if we want to go to 9, then we have to crash another one off of CE. And again, C is no longer available, so we can only crash E. And then to go down from 10 to 9 on path AD, A is no longer available. It was only available to crash 1. So we're going to crash now D for 150. And so now to move from 10 to 9 weeks, we have to spend another $350. And then finally, to go one more week, to go from 9 to 8, again, we're going to have to crash D and E, another $350. So the total cost to cut 4 weeks off of this project is $1,100. So this is an example. There are actually 2 types of crashing problems. The first type is when it tells you how many weeks or how much time to crash. So this is an example of that kind. You just crash, again, only activities on the critical path and the cheapest ones that are available. Okay, so questions on this example? Okay, the last example is when you are not given an amount of time to crash. It just asks you to crash it to an optimal. And so probably to help you think about this example, let's just imagine that this is the length of a project and this is cost, okay? So on the y-axis is the cost, okay? And on the x-axis, let's just say this is the length of the project, okay? All right, so as you can see here in this particular example, we have some indirect costs, or we have some costs that vary linearly with the length of the project. All right, so the longer the project is, the more these indirect costs are going to be. All right, now you can try to save money by shortening the length of the project, right? So if you shorten it, you're going to save indirect costs, but when you shorten it, now you're going to spend crashing costs. All right, so this bottom line here is the cumulative crashing cost, and then this top one up here is the indirect cost. All right, so if you look at a total cost, it looks something like this. Okay, so this U-shaping line is your total cost. And so with this one, this type of problem, what you're going to do is you're going to keep shortening and shortening and shortening. and you're going to come down this total cost curve until you hit the minimum. There's only one minimum, and you will know you hit it because then you're going to start going up in cost. All right, so you're going to crash. You're going to keep crashing until these total costs go to a minimum and you start seeing them go back up. And that is going to tell you what your length or how much to crash. All right, so that's kind of the conceptual overview here. So let's go back to this example, the one that we just did, and let's just say now we have indirect costs of $150 per day. All right, so we still have 3 paths. As you recall, CE is still 12 days long. So if we don't do anything, let's just say we don't crash, we don't do anything, we will have indirect costs here of 12 days times 150 per day, or $1,800. So basically right here, this is $1,800. We're way over here at this and just indirect costs. We haven't done any crashing. So if we want to take 1 day off, all right, so again, we know that we're going to have to, CE is our critical path at 12 weeks. So if we take the cheapest activity, which is C, it's going to cost us $100. Our cumulative costs with crashes of $100. So we spent $100, but we've saved $150, because notice the indirect costs now are 11 times 150, or $1,650. So our total cost has gone down by $50. It was $1,800 when we didn't crash, and now it's down to $1,750. So again, we're coming down this total cost curve. And so what we do is we just keep going until we find a minimum. So you can see if we look at 2 days crashed, this last row here, we know that we have to crash A and E. It's going to cost us an additional $200. Cumulatively, it's going to cost us $300, but we're going to save another $150 on our indirect costs. So our total cost now is going to be $1,800. So now you see we're at $1,750. We've passed the minimum, and now we're starting to go back up again. So the optimal amount of time to crash is $1,750 with 1 day crash. That's where we had our minimum total cost. And so the answer to this question is the optimal crashing plan is to crash 1 day. We're going to crash activity C for a total cost of $1,750. Okay, so questions on trying to figure out an optimal crashing plan. Any questions on anything that I've talked about this evening? Any questions about the class or what's due this weekend? Okay, so just as a friendly reminder, your Chapter 3 homework will be due this Sunday. And next week we will have the final exam. And it'll cover the chapters that we've covered since the first exam. Okay, there is a question about the slack time. So again, the slack is just the difference between, for the path slack, is just the difference between the critical path time and a non-critical path time. All right, so it's just the difference. So you have to find all the paths. You have to find how long each of them are. The longest path is your critical path. The difference between that and the other paths is the slack. Okay, and that's slack, if you just think about it as slippage. It just is the amount of time that that path can slip without making the overall project late. Okay, any other questions? Well, we have only one more week of the semester, and I imagine all of you are going to miss ops. So I hope you all have a good week. If you do have any questions on the homework, feel free to post them in the course or email me directly. And then I'm in the process of having the exam dates changed so that on Monday will be the first day you can take your final exam. You'll have until next Saturday. I have not made up your final yet, so I don't know how many questions or anything there is, but I'll post a note once I have made it up and let you know more information. And it is a proctored exam, so you'll all have to get a proctor or use your remote proctor for it. The exam is open book, open notes. You can use your PowerPoint slides. Again, you won't see anything that is different from either what we've talked about or what you've had on your homework, okay? You can also use Excel or you can use a calculator. Okay, so I'm going to let you guys go, so have a good week, and this will be the last time we chat on the phone, so I've enjoyed having you guys as a class. I think you're wonderful, and I wish you all the best with the course and finishing your Troy University studies. There is a question. There was the date on the syllabus indicates that the final exam is next week. So what I'm in the process of doing is changing the date of the exam so that it's consistent with the syllabus. So the final will be next week. Okay? And this will allow you to spend this week on Chapter 3, get Chapter 3 under your belt, and then next week you can just worry about taking the final and then finishing your projects. Okay? All right, everyone. I hope you have a great night, and please let me know if you have any questions. Take care. Bye-bye.